Hello everyone, and we are back with some very good learning regarding perimeters and area. So let's see what do we have here. So first we have this something called, well, what do you want to call? Let's say I'm holding it like this. What do you want to call? Do I hear somebody saying diamond? No, not exactly. And what if I do it like this? Yes, it's a square. So what we'll try to see that how this square looks like when we'll actually draw it on a board. So I'll take my marker and I'll try to put some points over here. 1, 2, 3 and a 4, and let's say I'll name them as A and B and C and D. Now what do you think represents a square over here? So what probably I want to see is that if I measure this side like this, and if I measure this side like this, and third side and fourth side, so what I want to see that do they measure all as equal or not. So for that we need a measuring tape, and we do have a measuring tape. So I'll just take and try to measure. So this is coming as 10, 11, 12, 13 centimeters, and again around 13, and again around 13, and again around 13. So when we say that when all sides of a square are same, and in this case we do have 13 centimeters as side length, so we say that all these sides are same. So we say all sides are same. Now the only difference over here which we want to have with other four-sided figures would be that probably we want to check its angle as well. So when this one angle is 90 degree, that will automatically imply that when all four angles are 90 degree, so we'll say when all angles are 90 degree and when all sides are same, so we will have a square. Now what happens when this square is tilted a little bit? So what happens, the base is same over here, but this will get tilted like this a little bit, yeah? Now this angle is not 90 degree. So in that case probably you want to say that since the angle is not 90 degree, so then it's not a square. It's not a square because its angle is not 90 degree. So what do we say in that case? That it's more of a parallelogram. It's more of a parallelogram just because its angle hasn't changed. So that's one thing regarding square. Now if I want to go to my younger brother of the same family, so that's more seem like a rectangle. Actually you can say that both are brothers of the same age. So what happens in this case is that if I'll try to just rub and see that what are the conditions in terms of a rectangle, so probably I want to see it this way, that this is a rectangle, and again I'll try to put some points which are 1 and 2 and 3 and 4. So probably I'll name them as A and B and C and D. Now when all of them I try to measure, so I see one of them is of bigger length and the other is of smaller length. So either I can take them as L1 or L2, or mostly as in standard, instead of L2 we take it as B, which is nothing but breadth. So when we have dimensions like these, we say that they are mostly rectangle. Why? Because rectangles have similar quality like that of square, that they have angles as 90 degree. Angles as 90 degree. And 90 degree among what? So among their sides. Among their sides they have the two sides have angles as 90 degree. The one thing which differentiates a rectangle from a square is that the lengths, all lengths are not similar. For example, if I try to measure one of the lengths over here, so when I try to measure one of the lengths, it's more like a bigger length over here, which represents as 20, and this represents as, let's say, 11, 12, 13, 14. So one of them is 20 centimeters, and the other this breadth is coming as 14 centimeters. So the difference between a square and a rectangle, apart from similarity of having angles as 90, the difference is that one length is different, but the other length, which is a breadth, is quite different than the first one. But when you compare, the opposite lengths are same. For example, if my first length is 20, then my second length will also come as 20. Now what if I go back to my rectangle and analyze again that this above length of 20, it's obviously this yellow or orange color which you see over here. When this 20 is same as this 20, so the opposite sides as well, like 14 is equal to 14. So if you see by color coding like this, so this yellow or orange color is the same as this side in length, and this red color is same as the opposite. So in rectangles we do have 90 degrees, but our lengths over here, opposite lengths are equal. So that's what differentiate. And if we try to just compare both of them, so we can say a square has all sides as equal, but the rectangle doesn't have all sides equal. Now we'll just try to rub them, and before that, okay, so first we try to rub these dimensions over here and just see that what happens if our angles change. What happens if our angles change? So now whenever angles change over here, what will exactly happen is that probably our angle might change when there is a slight tension or pressure over here, the same which we just did for a square. So when we put a pressure over here, the angle changes. So now we can't say that all angles are 90. As you can see, we can't say that all angles are 90. So probably it has changed to a different figure, but having the same lengths, the angles have changed. So we may want to say that this is having parallel sides, that is the opposite sides are parallel to each other, that is they will never cross. And with that the word comes which is called more of a parallelogram. And obviously the square and rectangle both come as part of parallelogram. So when we talk about parallelograms, both square and rectangle come as parts of parallelogram. That's why they're very similar to each other. Now next thing which we want to point out, that since we're studying about perimeter, so let's say what's the perimeter of an rectangle. So when I take this, I'll draw this rectangle like this, and when we talk about perimeter, as we discussed earlier, perimeter is something which is taken outside, which is measured outside. So if this is my L, that is length, and if this is my breadth, so probably I want to see the perimeter would be, as we know, perimeter is sum of all sides. Perimeter is sum of all sides. And now this is one length which is L, but the opposite as well will be same. So I can say probably this is L plus L. And what is this? This is B. So probably I want to use a different color. This is B, but this opposite side is also same as B. So I'll say, okay, sum of all the sides will also have B plus B. And so when we add both of them, this will become 2L and this will become 2B. Now when we take common factor over here, 2 comes as common and this L and B come inside, so we get 2 into L plus B. But essentially, how does this formula of perimeter of a rectangle equals 2 into L plus B? It comes from a common root formula which is sum of all the sides. And one thing to identify, that can we use this formula for a very strange figure like this. For example, we have a very strange figure like this, or we have another figure like this. Can we use those formulas for this? Well, not exactly. So what we'll do over here, that when we have these kind of figures, and let's rub and try that what happens with these kind of figures. So let's try to get back to our calculation of perimeters. We'll try to replicate one of the figures over here, and one of the figures over here is like this. So when we have these kind of figures, so in these kind of figures, what we really need to do is we need to understand that what is perimeter, and we know the perimeter is mostly outside, yeah. So what we'll do, we'll calculate the total amount of lengths over here. So for example, first I'll calculate this length, and then I'll add this length, and then the third and the fourth. So when we keep on adding the lengths over here, the total amount of lengths will give me perimeter. Area, as we discussed earlier, we'll try to just divide them into a number of squares like this, and we'll calculate the number of squares, and area would be nothing but area is equal to number of square units, number of square units. Now we did discuss square, we did discuss a rectangle, but now we have a new friend, and let's say hello to a new friend, triangle. Now this triangle over here, if you just try to rotate it and see it from a three-dimensional angle, what kind of triangle do you think it is? Yes, it's an equilateral triangle. Now what does equilateral means? That all, let's try to draw, let's say, why don't you catch up and draw like this? Okay, so let's try to delete this, and let's make some room for our new friend. And by the way, when your new friends come to your home, or even your old friends, do you give them a room? Please do give them a room, because everybody needs some shelter. Yeah, okay, thank you. So make some room for your new friend, and I would be more than happy to give it a space. So I'll just draw a rectangle like this. So this would be A and B and C. Now my first priority over here is to find this thing called perimeter. Now this perimeter over here, which I really want to find, and I'm just forgetting which is the formula for perimeter. So I just learned this formula, perimeter is equal to 2 into L plus B. But is it going to apply for this? Oh, not exactly. Why do you think not exactly? Because yes, that formula was for something called a rectangle. But is this a rectangle? Not exactly a rectangle. This is very different from a rectangle, in fact. So perimeter has a base formula which we know is essentially sum of all the sides. So this is equal to sum of all sides. And sum of all sides would be like, if this is 10, let's say, so this is be 10 and 10 and 10. So when you add all these 10 centimeters, 10 centimeter, 10 centimeters, essentially that is going to be perimeter. So 10 plus 10 plus 10, if that's the case, so it would be 30 centimeters. Now what would be area of a triangle? That's what we want. So probably what we want to see, that what if I remove this, what if I remove this triangle and we join one more like this. Suppose if I'm going to remove one of these from here, and we are going to take one of the we call them nexus actually. So if we join these like these, and I'm going to make that triangle into more of a rectangle, so what happens exactly, that now my triangle has turned into a rectangle. Now when my triangle has turned into a rectangle, I'll place it again, and if I tilt it like this, so what does it mean? Essentially my area of triangle comes out exactly half of a rectangle. Now how can I prove it? I can prove it probably this way, that I'll rub this space and try to make a rectangle like this. Let's say I'll make a rectangle like this. Now what if I divide it into two parts? So this one rectangle, when it's divided into two parts as two triangles, and we know area of one rectangle is equal to base into height, which is nothing but the, yes, and when we are finding the area of a rectangle, we know area of rectangle is base into height. Generally, we are taught that it's equal to length multiplied by breadth. But why we are talking about base is that essentially this length is nothing but base. Yeah, and this height is nothing but equal to breadth. So the base formula, which I feel personally is very important for finding area, is area is equal to base into height. Now when we know this, when we actually know this, that area is equal to base into height, and we are actually finding for a rectangle, now as shown in the figure, if we are trying to take a half of a rectangle, we will essentially get the area of a triangle. So what we can derive from it is that area of triangle, area of triangle is nothing but it's equal to half of base multiplied by height. And this essentially will work for any triangle. Any triangle, it could be equilateral triangle, it could be right triangle, as you can see over here. The formula for triangle, area of triangle, will be half into base, and B represents base over here, half into base into height. And why half? Because we derived it from a rectangle, and the half of area of rectangle comes out as the area of triangle. Now when we try to just remove this and go to our new friend, and who is our new friend? I'm really curious. And okay, I just see this rope over here, so let's try to see if we can make something out of it. But before we do that, probably I want to make some space over here so that we can just work with our new friend, and just I want to understand that what can we do with this rope. So probably I have some space over here, and let's see, I have this long rope, and I'll put it like this. Oh, I see some space, so probably I'll put my pen aside, and what if I try to join it this way? So alright, so now we are done making this shape, and oh, what is it? So I got it. So this seems like a circle. Now the circle we have over here, and the last time I remember we were discussing about circles, what we really did, I think, was we probably took a circle and we probably divided them into various pieces. So can I find some pieces around? Yes, I do have some pieces over here. So let's see how much this portion would be out of the total, right? So if I'll try to just manage to see that how much this portion would be, and I'll try to join them, and let's see, I have 1 and 2 and 3 and a 4. So I got 4 over here. Yeah, so when I got 4 over here, so rest of the 4 can come over here. Let's say it's a total 8, and 8 if are coming in the bottom half, next of the 8 if comes at the top. So probably I guess it's 1 out of 16, because 8 plus 8 gives me 16. So let's try to see if I'm going to make something out of them. So what I'll do is I'll probably try to make some space and adjust them and see what total area they can make. So probably I want to use some water to put it on the board. So I got this one over here and this different color. I'll try to adjust it like this, and it might take some time, so you guys want to have some snack or something, you can go. Alright, so we are still trying to stick, and now this part will go over here above, and this part over here will go as bottom, right? Like this. Now do you see any similarity in the shapes in which we discussed. Let's take some shapes. So I do have these square and these rectangle. So do you think they are similar to each other in some shape? And let's try to find as well what kind of lengths are we getting. So let's say I'm able to get this one length over here. Yes, I'm getting one length, and let's say I'm getting a breadth over here. So this seems very similar to some kind of rectangle, right? And probably in concerning to a circle, the first thing which always comes to our mind is a word pi, indicated by this. So now if I want to find the value of pi, we do know that pi must come as circumference divided by diameter. And what does circumference mean? That when I took this rope, what was the original length of the rope? And the original length of the rope was calculated as 74 centimeter. All I need to calculate now is the diameter. So I do have this tape, and I'll try to measure from this center. And what is diameter? The longest chord passing to the center is actually what we call diameter. Now what is our diameter when I try to measure? So I'm getting approx 23 point, let's say 56. So I'll divide over here with 23.56, and when you divide this using your calculator or actual division, we'll find this value will come approximately, let's say, and you can even do like this, 23 times 3, 3 3s are 9, 3 2 is 6, 69, and obviously this 0.5 will increase the value. So this will come out to be, when you divide, so this 3 will come over here, 3.14 centimeters approx, because 3 times of 23 will give close to 69, and when this 0.5 is considered, so that much time it will get close to 74. So it means 3 times something we are going to get, and the exact value of pi is 3.14 centimeter. Now using this formula, pi is equal to c by d, can we also find something called what is circumference of the circle? If you're wondering what is circumference, circumference is nothing but the outside boundary, which we used to call perimeter, in terms of parallelograms and rectangle and square. In circle, instead of perimeter, we just say circumference. That is the outside, this length, which is perimeter in most of the cases, we say circumference. Now through this formula we say circumference is equal to pi times d. So with this we can use this formula, and we can say circumference is equal to pi times d. D is what we know over here, diameter. And now suppose I want to substitute the value of d in terms of radius. So we should know what is radius. Radius is nothing but half of diameter. Now when we say that radius is half of diameter, so obviously diameter is r plus r, which is nothing but diameter is equal to r plus r, you can also say 2r. So what I can do over here is, instead of diameter I can write 2r, and my final formula comes out to be circumference of circle is 2 comes here, 2 pi r. Now what over here we have done, we have split the circle into many small parts, each being 1 out of 16, So these parts, when we have arranged over here, one thing which I'm wondering, that how do I find the perimeter over here? So the perimeter over here we know must be 2 pi r. What does it mean? That this should be split into 2 parts, that one part of the circle should be this, which will give me circumference, and the other part, the circular part, if you're wondering which is the circular part, so these are the circular parts. When you're joining, the circular parts come either here or they're coming over here, and the whole circle, when we cut from over here and we're facing this way, So half of the part of the circumference come at the top and half come at the bottom. So what does it mean? That this part 1 and this part 2 makes the whole circumference. And we know circumference is 2 pi r. So what is half of it going to be? It's going to be pi r, and the other half, let me make some space, and the other half will also be pi r. So when all of them will make pi r, so pi r plus pi r will give me essentially 2 pi r. Now this was something about perimeter. What if I want to make actually the area part? And I know it's kind of tricky. Okay, and now when we're trying to find area after finding the perimeter, circumference of circle, which was just 2 pi r, circumference is 2 pi r, let's try to find what can be the area out of this relation which we already have. Now for finding area, if you just remember using again, let's take example of the rectangle which we have over here, or a square will also work. So let's take, I'm taking a square this time, and I'm taking that what should be the area of the square. So I should know the base formula of area is equal to base times height. Now some of you will say that, sir, in case of area we have been taught that the formula is side square, so how come it's base times height? Well, yes, you're right, but you should understand that what is base over here? Base is nothing but one of the sides as well. So if you assume this as side, one base is side and the height as well side, so obviously the base of square will be side square. So the formula base into height works for even squares and rectangles, and obviously we'll try to find it to find the area of the circle as well in the derivation which we are trying to do. So now we'll just try to rub this side square and use base into height as a means to form the area. Now, what is base over here if I just want to see? So base, as we said, was pi r. So I'll write over here my base is equal to nothing but pi r. Again, why? Because 1 pi r I had above, the other pi r I had below, both of them forming the circumference c is equal to 2 pi r. So yes, this one length over here from here till here gives me pi r as the base. Now I got base as pi r, so I'm going to substitute base as pi r. Let me write base as pi r, and now I need something as height. So what can be my height? My height is nothing but this thing over here, and what we understand, if you see it carefully, it is nothing but the radius of the circle. It is nothing but the radius of the circle. Now this height, if it's equivalent to radius r, shall I write height as radius over here? Yes, we can write height as radius. Now this comes out to be pi into r, which is nothing but pi r square. So we can say area of circle is equal to nothing but pi r square. So now what have we done? We initially, just a little bit of recap, we initially started with figures like rectangles, figures like square. We used some rectangles, we used some squares, and we understood when their angle changes, they change into parallelogram, but they do have the base formula of area as the basic formula of area as base into height, and this perimeter is nothing but sum of all the sides. And when we want to find or derive pi, what we did that pi is equal to circumference divided by diameter. The circumference we knew was 74, when you divided this with the diameter, you're actually getting the final value as 3.14. Sometimes we also use it to say that 3.14 is nothing but 22 by 7. Both mean the same, so don't confuse into that. And yes, by using this cutting technique of circle, you can even try at home. You can just cut the pieces, rearrange them in a rectangle. We found that area of a circle being base height as the original formula, we got pi r as the base, r as the height. We got area of circle is nothing but pi r square. See, we can write area of circle is equal to pi r square. And that's it. Thanks a lot. Enjoy.